FLS, today we have a very cool component with us. It's called the MOSFET. This is basically a transistor. MOSFET basically means metal oxide semiconductor field effect transistor. So this is exactly a field effect transistor. It has three sides, as you can see here: the drain, gate and source. This MOSFET is a 5-volt MOSFET, and we are gonna see a very practical use case for this component today. So this is all we need for today's build. We have a breadboard, we have a variable resistor, a MOSFET, a motor, a 9-volt DC battery, and a lot of jump wires. So here is the basic idea. If we connect a 5-volt DC battery to a motor, it will run very fast. But if we want to reduce the speed of the motor, we can have a very high resistor connected in series to that motor, which will cause some voltage drop over here and the motor will run slowly. But the problem is the current that the motor takes is very high, so that will burn our resistor. So the solution is to use a MOSFET like this. So if we connect our MOSFET in the circuit like this, we do not have a clear path for the current to flow from drain to source. So we will take a variable resistor and connect it to the gate side, to the positive side of the battery. And if we increase the resistance to maximum, very little current will flow through the gate, which will cause the MOSFET to be active, and the current from drain to source will flow and our motor will run. Another good thing about using a variable resistor is that we can totally control the speed of our motor by changing the resistance. So here is how the circuit looks on the breadboard. Let me check if this works. As you can see, the motor turns on, that means the circuit is made. Now let me show you how we made it. The battery has this positive side connected to the resistor, and with the resistor we connected the gate, the middle part of the MOSFET, which is shown in the diagram. However, the positive side of the battery also has connection with the drain side of the MOSFET, which is important because when the resistance is high, we don't see any current flowing from the drain to source. If the resistance is low, the gate opens up and there is a little current from drain to source. If we open the gate more, the current is bigger, so the motor speed will be also bigger. So let's see how this voltage regulator works. As you can see, battery's negative side is connected to the motor, and if we connect the source of this MOSFET to the motor, it spins at maximum speed. So if we want to decrease the speed, we will increase the resistance just like this. Turning this part, it will slow down the motor. It's slowing down. As you can see, the noise also decreased with the speed. So it's very slow now. Let's turn this off. It's totally off. If we decrease the resistance again, the motor speed will also increase slowly. A little more. We will see many other cool features of MOSFET in the future videos, so I hope you liked today's video. And the circuit is very easy, so of course try this at home.